more like an outcome. Do you get it? We are familiar with some concept called Pythagoras, is that not it? When you learn something in Pythagoras, we're shown that we don't understand why somebody, let's see, more like you, let me just take off the squared components first. We are all agreed that if, let's say, you are here, A and B and C, this is your house. Do you get it? So you are moving here. According to this principle, all that we are trying to say is that somebody traveling here directly to this place will still get to your house. The same way, somebody who come to what B before what going to C is still what going to get to the same direction. And we are saying that should you add the distance from here to here and the distance from here to here, you should get the distance what as for traveling what A to C. So in a case like this, what we mean is that A to C is what your main focus, is that not it? Going to your house is your main focus. That is your resultant. More like your outcome, the outcome of every day. If it's a journey, you are embarking on a journey where you are looking at to what? To get to your destination, which is your house. So that is the result of what you want to see. So the entire idea of vectors and resultant is all about that. If you are from destiny A and you are going to a house, we don't really care about where you pass. But all that we are trying to say is that the most possible straight route from wherever you are to your route, and however way you may meander, do you get it? To get to your house, the distance, if you sum up all those routes and then the straightest route that you could have gotten to your place, it is what? Equal. That's basically the concept about Pythagoras. And it's the same idea that we are somehow going to what? Use in understanding resultant of vectors. Resultant of vectors go with this same principle. More like we have a very straight line like this, and then we are seeing this, let's say that. The difference between probably what I'm drawing now and that of the first one I drew was that for Pythagoras, it must be what? A 90-degree, a right angle triangle. But this one that we don't really care. Do you get it? So it's more like we have A and we have our C. We have B here. So it's more like going here, coming here, more sort of the same as what coming directly. So it goes with just the concept of Pythagoras, just that the feature that I mentioned is the only distinctive feature, that is the right angle property. So what then is magnitude of what the column vector? That's the first thing we are looking at. According to our schedule, the very first thing we are looking at is what? Magnitude of what? A column vector. So let's say A, magnitude of a column vector. Alright, magnitude of a column vector. So when we could have something, normally we put it like this. So the same way, just like the way I use ABC, you could use any consecutive alphabet. It could be anything, it could be P, Q, R, it could be anything, so long as they are consecutive, just for us to get our resultant. So we could say that AB, and write it this way, what we basically mean is that it is what vector what? B from A. Understand it very well? Yes. How you pronounce it will also influence how things happen. When you do it this way, you are saying that vector B from what? A. Do you get it? So all that we are trying to say is that if you want to find the magnitude of a given vector like this, it is written as either what? AB this or AB this. Very, very important. Very, very, very important. This key, this is one of the important things you should understand. So the moment you hear the word magnitude, it means that we are talking about what? More like the measurement. Do you get it? So the moment it happens like that, this absolute bars should be what you place there. If you forget to put this on top, it's still correct. So it's either you put it this way or that. So this is the first step. This is the first step. So let's solve an example together. So it follows. Okay, let me finish with the theory first before we go through the numerical example. So from here, it follows that if let's say we have if let's say AB is equal to, let's say, XY, like this. If you have AB equal to XY, then we can say that I can write it either AB like this, or so let me just join them with the equal to sign. But you can just use any. I'm not saying you should use both. It's equal to what? Because of the magnitude sign plus what? Y squared. So this is how we calculate for what? The magnitude of what? A column vector. This is a very simple formula, simple approach to calculating the magnitude of what? A column vector. So first of all, just understanding that when you have a vector like this, vector B from A, it could then in magnitude sense, it is written this way or that way. And then in a more practical sense, if you have AB, vector AB, in the form of a column vector X and Y, then we write it this way, that root of what? X squared plus what? Y squared. So from this idea, find the magnitude of PR. Okay, so now comes the example. Find the magnitude of, let's say, PQ is equal to, let's say, 10 let's say 24. Find the magnitude of this in the next 1 minute. Let's find it quickly. Yes, what did we get? What did we get? What?
It's 26 units.
It's 26?
Units.
26 units, okay. Did you get the same? Alright. So that's correct. So at least it means that our first objective for magnitude of a column vector at least is achieved. So what you're going to do is you go through the other two, then after that you solve quite a number of examples to make sure that we're all on the same platform. I hope you're cool with that. Alright, so let's move on to, when you say a zero vector, what do you mean by that? How do you understand zero vector? If you say a vector is a zero vector, what does it mean? What do we mean by that? When you say zero vector, what do we mean by that? Yes, who can help? Yes, any idea?
Maybe a vector where one of the values is 0.
One of the values is 0. Yes, any other idea? Any other idea? Ajo, when you say a zero vector, what do you mean by that? What we basically mean about zero vector is a vector that has its both components being 0, not just one. Because when you get to where we do addition and subtraction of vectors, you realize that it is not always the case. Like if you have just one, you can't call it a zero vector because one may distort it. So it is a vector is said to be a zero vector if the components are both 0. So an example is what? An example is sort of this having 0, 0. That is how it looks like. So a vector is said to be a zero vector if its components are both 0. An example is what I've indicated. Now let's move on to the let's prove something shortly, and then let's get it clear before we move on to the addition and subtraction of vectors. The addition and of vectors. So addition, let me write it as C. So addition and subtraction of vectors. Addition and subtraction of vectors. So let's say resultants of vectors. Resultant of vectors. Before that, let me prove something. Before we started, I wrote vectors to be in a state like this. So when I said that, it's called the vector of B from A. But I see there's something funny about how you write small letters and capital letters when it comes to vectors. You get it? When I write, let's say AB like this, if you want to write it in capital letters, it is rather what? AO plus what? OB. Why do we say that? We can only say something. We can, just like the way I did this over here. You saw A, C, B. Do you get it? You realize that we are moving. Do you get it? We are moving. So we are moving from A to B. Do you get it? And then we are moving from B what to C. That's how come when we wrote AC vector, we call it what? AB plus what? BC. It's like it's a continuous something. There must be that kind of continuity. Do you get it? That is the concept in your vectors. There must be a continuity. There shouldn't be any hiatus or a break anywhere. So that is the same dynamic that is coming here. So what that this thing is trying to say is that if you are to move from A to C, which is our resultant, where the exact position where you want to be, then we should what? Move towards A to B, then from B to what? To C, as is stated. So the same way, now I've written AB. It means that our final destination is what? A to B. Do you get it? And we are having, it means that we can move directly from what? A to B. However, over here, you can't just write, in vector sense, you can't just write A and then plus B. There must be a starting point. So more like there's a midpoint somewhere. Do you get it? So it has to be A to that midpoint, or I'm just calling it midpoint. That's not the right word. A to whatever point it is, which is probably 0. Then from the 0 to the B before we get to B. Do you get it? Because in between the A and the B, there are a lot of points. Do you get it? That's why we categorize it this way. So that is why we write it this way. That's why it's rather AO. Do you get it? O from A. That's how we call it. And then what? B from O. Do you get it? So it satisfies this idea. So because of that, if you are to write this, normally it should have been what? OA. Do you get it? But because of the idea of resultant, because what you are dealing with was resultant vector, and I've explained what resultant means. Moving somewhere, it has to be continuous. I don't see anybody who is going to a destination, then you come back and then go, and then we call it more like a resulting something. No. Whatever move you make should be what? A progressive something leading to a destination. So that makes this what? Sort of what? A negative. So it becomes what? A negative A in small sense. Do you get it? Because this movement distorts the normal movement where it should have been OA. Do you get it? So it makes it negative. And this one follows what? The actual, what do you call it? Progressive movement. So it becomes what? Small b. Do you get it? So that is how it goes. So if you want to rearrange it, then we have AB is equal to B minus A. Do you get it? So anywhere you see what? A resultant vector. So you can either write it this way, or you can write what? Or this one will come first. This one became negative. So it's more like this same thing became more like negative AO like this. Do you get it? Plus OB. This is. So if you want to write it in the capital letters, it becomes what? OB minus AO. Sorry. Do you get it? So that's the same as what? B minus A. Do you get it? So whilst you read other textbooks, other elective maths books, you realize that they may not take their time to explain why when anytime you have what vector AB like this, they represent it by what? More like where it is ending on. Whatever alphabet is ending on, its capital will come first. Then what the one that came before that is smaller one word will come that way. But the intuition behind why we are changed to smaller letters is because of this dynamic that I just explained. Do you get it? So let's note this. And this concept is what we call negative vectors. So from here, I just introduced it because what we are about talking about is going to come is going to come across. That's why I introduced it. So this, what just happened at this area is what we call what? Negative what? Vector. Negative vector. It's more like opposite. Something more like you have to move in a progressive way, but you move at a point in time, then you come back. It's like there's now a dynamic between the A and then the O. Do you get it? And it has to be set up another point where you now go and move from there to another side. So that is the reason why it has to come this way. Any question at this level? Okay. So let's write something quickly under this. Let me dictate something, just a line or so. So after writing this caption, probably after writing this, or you can see, since the endpoint of AB, if I say, can I clean this entire thing? Okay, let me give it this side. So since the endpoint of AB is written this way, vector AB. Since the endpoint of AB is B, and the initial point of BC is also B. Since the endpoint of AB is B, and the initial point of BC is also B, we can therefore write the resultant as AC AB plus what? BC. It's that simple, as I've earlier explained. We are saying that since the endpoint of AB is B, do you get it? And the initial point of BC is B, it means that we can then write the resultant of AC as what? AB plus what? BC. So this basically means that anytime, no matter the alphabets that you are given, so long as they move in a progressive way, there has to be that flow. Do you get it? The end point of the first session should begin the next session. I hope we are clear on that. I told you that this movement in vectors is for progressive. So the end point of the first movement should be what? The initial point of the second movement. It is only through that mechanism that you can boldly say that there has been a progressive movement. There has not been any gap left in between anything. And that is what I have drawn as well. Do you get it? So let me take it again. So since the end point of AB, I wrote it there, is B, and the initial point of BC is also B, we can therefore write the resultant as what? AC is equal to what? AB plus BC. So let's take an example, or let me make it more open and general. So given that, have you copied inside? Or you are okay? I want to clean the entire board, can I? Okay. So let's take this example. Given that vector PR is equal to, let's say, A, is equal to what? X1, Y1. RQ is equal to B is equal to X2, Y2. And C, or let me say PQ is equal to C. Then it follows that C is equal to what? A plus B. That's simple. It follows that C is equal to A plus B. That's simple. So how do we deal with this? This is an addition sign. So how do we add it? It's that simple. So it just becomes what? C is equal to, then you take the value, the column vector for A, which was what? X1, Y1. Then you close the bracket. After you just close the bracket. Then you take that off, you bring that addition sign. Then look at what? The variable for B, which was what? X2, Y2. Done with it. Then you close the bracket. Then you just sum the numerators. You give us a bigger bracket, then you sum the numerators. So x1 plus x2. Then the down here is going to be y1 plus y2. So this is how we add vectors. And it's the same principle that we use for what? Subtraction as well. So assuming there was a negative vector, what would have caused this to be maybe a negative vector? This one, in this particular sense, they defined the smaller variables. No, note the difference. This one, they defined the smaller variable. They said that anytime you see PR, it means what? Small a. Anytime you see RQ, it means small b. And anytime you see PQ, it means what? Small c. And they are saying that, therefore, C is equal to A plus B. So it's the same as writing that PQ is equal to what? A was what? PR, right? PR plus RQ. You realize that whichever way that you put it, you must make sure that the ending part of the first session is beginning the next session. Do you get it? And that is the only way you can calculate what? A resultant what? In something. Because assuming, so this is where the negative issue would have come in. If I had written PQ is equal to PR, maybe I've given figures like this, then okay, I can't put it in the equation like this. I can say that maybe I've given, let's say, PR like this is equal to maybe 2,4 like this, the typical question. Then I'll give you QR is equal to what? 1, 2. Then I'll ask you, find the resultant vector PQ. So we are going to solve this. And then this is very easy. Do you get it? But I'm just introducing where the opposite or what the negative vector issue comes in. Now, how do you even know something has changed? Sometimes questions about vectors are quite tricky. If and only if you don't pay attention to what I'm about saying. To be at the safer side, anytime you get a question like this, try and draw it. Let's just assume, or if let's say you don't have space to draw, at least make sure the alphabets in question, you've lined them according to the alphabetical order of the ABCD. Do you get it? So here you saw 3. You saw PQR, ABCD, MNOP, QR. Do you get it? So you see that is the flow. So this means that if they are asking you to get what? PQ. If they are asking you to get PQ, and this is PQ, then it follows that principle that the ending part of what the first session should begin the next one. So which one is the ending part? These are the two. So the only thing that is left is what? The R. So R will be what? The ending part. Then the P, which is the beginning letter, will come. Do you get it? Plus this same thing will have to begin, and then it will end with what? The Q. So this is how the resultant vector will be formed. Are you okay with how to form the resultant vector? Are you okay? Good. So this is how it will be. Now, after getting it this way, then you come to look at the variables that you've been given. Are they in that form? Did they give us PR? Did they give us RQ? Then you come and look through. They gave us PR. Good. 2, 4. Did they give us RQ? Oh, it has been 10. Do you get it? But the good news is RQ is equal to negative QR. That is the golden rule. That's the golden rule. So that's the way to convert whatever thing that they've given you to suit your resultant. Do you get it? So RQ is equal to negative what? Do you get it? QR. That's all. So in this case, they gave us what? 1 and 2 to be what? QR. So it will be what? 1 and 2. Is that not it? So it will be 1 and 2 negative, like this. Do you see it? So the answer for RQ will be what? Negative 1, negative 2. So come and then clear this conception fast. Then after that, you can now go ahead and come and put it back there. Negative 1, negative 2. And solve for what? Your resultant PQ. Are we okay? You see, it's that simple. So the concept of negative vector, or some books call it opposite vector, some call it negative vector. Either way, it's the same thing. Concept of negative or opposite vector. This is all that is all about. So far, what we've done is trying to just hit on some major things. The first is knowing that when it comes to resultant vector, they move in a progressive way. So you must make sure that whatever is ending for the first session is beginning what? The second session. The moment you realize there has been a distortion in terms of arrangement in this particular movement, then you know that it is what? Satisfying the concept of what? A negative or opposite vector. So you correct it using this simple principle, and then you get what you needed to complete the cycle and continue with it. So how do you complete this? So just like I showed you over here, it's that simple. So PQ becomes what? Then you draw a bigger bracket like this. It becomes what? 2 minus 1, 4 minus 2. Then the answer becomes what? 1, 2. And what? Your resultant vector PQ. Are we okay? So you realize that in all this, I've stopped using the word magnitude. You see, I've not said anything about magnitude. So one thing you must always know is that you can only find your magnitude, the magnitude of a particular thing, when you know its resultant. Do you get it? Because remember the formula that we gave to magnitude, where you have a root of what? S squared plus what? Y squared. So in this case, let's say I'm giving you a question. I would have asked you, after writing this, A, find the resultant vector PQ. Then II, find the magnitude of PQ. Do you get it? So after you have gotten 1 and 2, then you come and apply what? You put it in this way. If you want to tackle magnitude, don't forget to bring this. If you forget this, you are still talking about resultant and you are wrong. If I'm marking you, this one, it means you don't even know what you're about. Because magnitude is talking about distance. Anytime you're talking about distance, bring your bars so that you know this is what you're talking about. So if you're talking about the resultant, it's still the free one to add the voice one. So the B, in answering the B, which would have been resultant, will then follow what? Square root of what? 1 squared plus what? 2 squared. You simplify this, and then that will be what? Your magnitude. Are we clear? Resultant vector PQ. We said find what? The magnitude. So instead of I can just write find what PQ like this, and that is what goes with this formula. So it's just a matter of simplifying this, and you are saying that you get 5.
We still get 5.
So
Root 5.
are we really going to get 5?
Root 5.
Yes, it's 5.
We are going to get root 5. Okay. So are we through?
Yes.
Alright, so basically this is what today's lesson was all about.